Hi everyone. Thanks for listening to my talk on Kotlin Multiplatform. Kotlin Multiplatform, a word I will be saying a lot today. We'll see how many times I get it wrong. So first up, a little about me. Every Easter and every Christmas, every sort of holiday, I go down to this little town called Bilue, down on the Mornington Peninsula, about an hour and a quarter from the city. Nice little seaside town, and I go down there and I spend a lot of time with my family. So when I'm down there, there's, my dad is there, he's there in the bright blue, my nephew comes along, the little one in between, and then my uncle also there, and his family will come along. So my cousins, my second cousins, various boyfriends and girlfriends and wives and husbands of all this big group. So every morning we go down to coffee at 8 a.m, and it will be a different group every time. So sometimes there might just be a small group of us, other times there might be like 15 or 16 of us. Completely depending on who's hungover from the night before, who feels like a walk, who managed to wake up in time, or who just feels like coming down. So, of course, everybody wants to be the big man and throws their credit card and says, get a round of coffees for everybody. This happens every single morning. And, usually it's left to me to make the list of who wants what. I've got to remember whether it's hot or how many sugars it's going to be, what variation on a milkshake they'd like. So I have to remember this every single time and count who's there and work it out. And I thought, surely there's an app for this, and surely I could make one myself. So I decided to make Coffee Run. This is an app which will allow me to make these coffee orders much easier. But of course, I can't just make it for Android, which is my usual place. I have to make it for iOS as well, because my family all use Android because I've told them to. But my uncle's family, they all use iOS. So whenever they have a tech question, I'm hopeless at helping them. But I have to support both platforms, so I can't just write this for Android. And as you know about me, I only write things for Android. I do not know any Swift. I only know Kotlin. So what am I going to do? Kotlin Multiplatform is the answer for me. If you don't know what Kotlin Multiplatform is, I'll take you through it now. So when you're making a traditional native mobile app, you've got Android and iOS, for example. And you're going to be writing logic and code in a UI layer, a domain layer, and a data layer. And you'll be writing completely separate code for both platforms. The idea behind Kotlin Multiplatform is sharing these layers. So we can share our domain and our data, only writing this code once, and then applying it to both platforms and running it on both platforms. It might be similar to what you might think of when you think of Flutter or React Native, but in that case, the whole app is written in those languages. In this case, we might only write part of the app. We might only write the domain and data layer in Kotlin Multiplatform. But of course, I don't want to write any Swift whatsoever, so I'm going to use Compose Multiplatform as well. And this allows me to write my UI layer shared across both platforms, so I don't have to touch Swift, I hope. Also, if I wanted to, I could also deploy my app out onto the web as well, or many other platforms, and share this code with more and more places. Even if I was running a server, I could use Kotlin Multiplatform on the server as well, and write my logic there for the back end as well. So I could write once and run everywhere. That's the dream, right, for everybody? Yeah? So what platforms are supported? Google and JetBrains work on Kotlin Multiplatform together, and they've come up with a list of tiered platforms. We've got the tier 1, which is fully vetted and reliable. Sorry guys, it's a bit distracting, thanks. Tier 1, which is fully vetted and reliable, we can use this with confidence in production. So this is Android and iOS and our desktop platforms as well. Tier 2, this is the ones we might use with caution, so macOS and Linux, not quite tested completely. And there's the untested experimental areas, which is some watchOS, Windows, JavaScript, and web as well. Gradually, these will graduate themselves into higher tiers. I'm just going to focus on tier 1 because all I care about is Android and iOS for this project. So let's get started. How easy is it? Spoiler alert on this. Originally for this talk, I wanted to sort of do a lot of live coding and step through this. I thought, oh, I'll just get a hello world working for you guys, and that'll be a good talk, right? Well, this was actually a lot easier than I expected to get started. So there isn't really much live coding I needed to do. It's more in the logic of the actual app. And so I found it was a lot easier because I was already an Android developer. So obviously I was already quite familiar with Kotlin, the development environment, and lots of other things I'll talk about in a moment. So it was quite easy. So I'm going to focus mainly on the lessons I learned along the way while building this app, because I think that's where the real value is, to see what's good and bad about Kotlin Multiplatform. So how do we get started? We can use Android Studio, and there's a lovely plugin called the JetBrains KMP plugin. And this will allow us to get our usual wizard to start a new project. So we can use the new project template or the new module template if we want to just create a Kotlin Multiplatform module. I'll talk a little bit more about that later. So when we start a new project, we need to make some decisions. Which platforms are we going to support? So in this case, I've chosen Android and iOS. And I can also decide whether to share the UI or to not share it. If I want to actually write native UI, I can if I want to. So then we are presented with something like this, which if you're an Android developer in the room, it might be quite familiar. We've got our Compose app. It looks like we've got some other modules there. That looks pretty logical. Common, that seems right. That might be where we put our Android code, and probably our common code. There's some Kotlin in there. Yeah, okay. And then we've got our iOS main. Yeah, let's put iOS in there, but we see there's some Kotlin code in there. What's that doing there? And you might think, oh, it's a bit strange. So one of the lessons I learned was don't always use the Android file viewer. So if you're an Android developer, you would use that Android view all the time. But when you're using Kotlin Multiplatform, you don't want to, because it will hide some things from you. You want to use the project view instead. And what this gives you is some access to some of these iOS configuration files, and you will actually need to look at these. So I do recommend when you are working with Kotlin Multiplatform, use the project view so that you can see everything that's going on. We can also see that in our Compose app, we now have our Android main, our common main, and iOS main. So we can see we've got separated code for Android and the common, and then again the iOS as well, if we want to run different code on each platform. So what do we share between native Android and Kotlin Multiplatform? We share Kotlin, obviously. Gradle. So you do a lot of your build scripts with Gradle, and that's very similar to what we have on Android. So let's take a look at what we've got here. We have our Kotlin Multiplatform plugin. That's important. And then we have our specified supported targets. So I'm supporting, in this case, Android and also iOS. In this case, for iOS, we need to list the ARM device and also the simulator separately. And then I have platform-specific configurations. So the Android one on the left there, that looks pretty normal. We've got our default config, build types, all the things you might be used to if you're an Android developer. And then iOS, we can actually access the config through Xcode. And you do have to run Xcode in order to be able to run the simulator, which might be a bit strange for people who haven't run it before. I did have to ask my iOS friends, some of which who are in the room, how to use this, to use Xcode, because it was crazy for me. So you can find all this information out in the apps. So we can also use our dependencies in Jetpack that we might be used to for Android development. Some, but not all. So if we look at how our dependencies are laid out, we do this again in Gradle. We've got our Android dependencies. So these are ones that are only going to be used for Android-specific code. I'll show you some of that in a moment in the demo. Then we have our common dependencies. So this is dependencies that are used in common code. And if we look here, you might notice that we're using this Compose instead of libs. And that's because this is coming from the Compose Multiplatform plugin. They've actually got a whole set of Compose dependencies that are included with the plugin that you can include. You don't need to include these separately in your libs file. So we can see that we don't have our activity in our comment section. We have that in Android. But in common, we have all the things that we're going to share. So items for the UI, some life cycle stuff, and we can use that. But what about our iOS-specific dependencies? Well, you can't forget about them entirely. You don't need many, but some things you want to do might require some iOS dependencies. So I did have to write some Swift code, unfortunately. I did have to learn about Swift Package Manager. And then I took this really unfortunate detour into CocoaPods because one of the dependencies I wanted to use, Firebase, said that you needed to use CocoaPods, and that was a bad choice. And I spent quite a bit of time on that. When you're adding your dependencies in Swift Package Manager, you can just add them in Xcode, so you don't have to do anything in Gradle for that. But you do need to make sure you add them there so you can use them within your Kotlin Multiplatform app. Yes, that did take me a bit of time to learn. So the Jetpack libraries that we have available to us, we have stable, commonized, and alpha. Again, 3 tiers. And several of our usual libraries that we might be used to are broken into these tiers. This is an old diagram. These are constantly being updated every day. So they're constantly moving these libraries into stable as they test them and get everything working properly. So definitely go check out the up-to-date list. But the key factor is that the Jetpack libraries are gradually getting migrated into Kotlin Multiplatform compatible, which means you can use everything that you're used to. If we have a look to make, when you are including these dependencies, we can see in Kotlin Multiplatform, for our Android only, we're just using Android X activity. But for our multi-platform libraries, we have the org.jetbrains package group rather than Android X.lifecycle. So if you're going to include a multi-platform dependency, definitely check the group name, because if you're just copying and pasting from an Android website, you'll probably get the wrong one. So definitely double check some of those things, because you will get really weird errors if you don't do this. So what about non-Jetpack libraries? Well, there are a whole bunch of different ones that have either migrated to Kotlin Multiplatform or ones you can use instead that have been built natively for Kotlin Multiplatform. So if we have a look an example here, if you're used to using Retrofit, we might use Couture instead. Or if you're used to Hilt and Dagger, instead we'll use Coin. So you do have to make some different choices depending on whether you're supporting Kotlin Multiplatform. But some of these are quite similar, like Coil, it works for both. I think Timber now works on Kotlin Multiplatform, but these are gradually getting updated. So definitely go and check your favorite library and see whether it's enabled or not. A great resource is this one here, klibs.io. This is a whole bunch of Kotlin Multiplatform available libraries, which you can take a look and see what's available and what percentage of the API is actually migrated to Kotlin Multiplatform. Because the key factor is not all of them. And that was where I got one of my next lessons, was I was integrating Firebase and using the Git Live Kotlin Multiplatform implementation of Firebase, and did not have much success. So I thought, okay, making this new app, it's going to need to have some authentication. I'll start with login, right? That's pretty simple. Make a login screen, make an API call, do some login. That'll be great. Yeah, that was a bad choice. So to use Firebase, I needed to add dependencies to common main and SPM, which, as I showed you before, was okay once I learned what SPM was. I did require Swift to initialize Firebase, so luckily I made Gemini do that for me. And then when integrating authentication, I had a lot of problems. And this was where the SPM package and the Git Live SDK were out of sync. Because they're built by 2 different groups of people, some of the methods I wanted to call just weren't there in Git Live, or vice versa. They said it was there, but it was not available in SPM. And this involved the dynamic links that required for like email authentication, and which has sort of been deprecated now, but Git Live still had it in there, but the SPM dependency didn't. So I had a lot of problems with this, and it pretty much wasted a week of my development time, and pretty much an entire coding night where I had to ask for the iOS people to help me. So when you're doing this, it really pays to look at the API coverage. Have a look at what is enabled and what isn't. If we look at this, it's definitely not even. If you look at the top here, authentication, it's 80%. So I thought, oh yeah, I can use this, but actually I wanted the 20% that wasn't implemented. Just knowing me, that was right. Even if we look at like Crashlytics, 10% down here is only implemented, but I think pretty much everybody uses one method in Crashlytics, and that's just monitor for crashes, like that's it. So we probably don't care about that too much. But yeah, it really pays to look at what is implemented. Another factor with the GitLab Firebase is they'd made a choice to use infix notation for when they're doing the filtering of data, which sure looks lovely, but it meant that every time I Googled for how to do something, the regular Firebase SDK does not use infix notation. And also Gemini, when I was trying to get the agent to do things for me, kept suggesting the wrong way to do it, and got into a cycle where it's saying it's wrong, but it actually wasn't wrong. So sometimes the slight differences in the API and the signature for some of these methods can really make a big difference in the end. So I recommend checking this out, not just assuming you can just copy and paste Android code. So once we've covered our dependencies, we can look at our dependency injection, and as I mentioned, not Dagger and Help, so we can use Coin instead. We can use our normal architecture patterns, so MVVM, clean, coroutines, anything that you're used to, you can do this as well. And Jetpack Compose, I mentioned before, we can use Compose Multiplatform. It's pretty much exactly the same as what you would use on Android. It's not like Glance that you use for watch development or for notification or widget development, where it's a different import. It's pretty much the same as what you have in regular Compose. So that's really helpful because if you've already built this for Android, you can just copy this part across. So I'll do a little bit of a demo and just show you some of the code. Okay. I'm not going to do any live coding. As I mentioned, I was going to, but I don't know. It doesn't make sense because it all looks the same. So we'll have a look at what we get with the file structure. So we've got our Compose app here. If I go in here and have a look in, firstly, we'll jump into the application. So we can see I've got my coffee run application here. Sorry, I didn't have that big for a reason. So we can see it's just a regular Compose application. We've got all our Compose, view models, all that sort of thing. And we jump straight into our UI with a normal nav host, all the same as what you might be used to previously. So let's have a look at how we how we get this on the screen. So we still have our Android manifest, and we still have our main activity for Android. So this is what will be called when we're launching Android, not when we're launching iOS. We have our normal create, set up edge to edge. You could have other code in here that does other fancy things if you want to. Initializing Firebase. And here's where I just set my content as the coffee run application, that application I showed you before. So that is pretty easy. That's pretty standard if you're an Android developer. Now, for the iOS side, that's the next part. If I jump into the iOS app down here, we have a bunch of different folders. We can see we have the configuration files, so the info plist here, a whole bunch of other files as well. What we have is the iOS app Swift. So this is where we enter when we're loading the iOS app. So we can see I've had to create this thing, whatever this thing is called an app delegate. Yeah, they laugh at me, iOS people. I made Gemini do this for me. I required this to launch Firebase. But we have our iOS app. This calls a content view, which then calls our Compose view, which has a main controller, which then launches our coffee run application, which is back to our application I showed you earlier. So there's not much you need to write in order to launch something on iOS. It all links back to the same thing. So the key factor is you don't have to do much in the Swift pile. And as you might notice, there's only, I think, 2 files? Yeah, 2 files in Swift in this whole application. We also do have some code that's Kotlin that's used for iOS. And I'll talk a little bit more about that later. But pretty much you don't have to touch a language you're not familiar with at all. Okay. I'll jump back here and I'll show you a bit more of the demo. Oh yeah, I'll show you a bit of the application as well. So we can have a look just at the application to show you a few differences. We can see here I've got my Android version here on the left in the black. If I turn off dark theme, it goes to light here, so we're good. So we can see it looks pretty much the same. And this is because I've used material theming. I have the same UI across both platforms, so it's going to look very similar. Yeah, we have our text fields act the same. It's all good. I can see that I can interact with it. I can add my coffee crew down here. So the people who are going to come to coffee with me. My sister here is going to be on the iOS version. She decides to take away her coffee. Save that, and it will update over here. So I've got all the communication working, and there's a fair bit of logic behind getting stuff like this working. If we have a look at the code, that we'll get all this stuff. There's actually quite a lot in here. So all of this stuff it's in the common main here. Where's Compose? Oops. If we have a look, there's a lot of code that actually makes all this work. So a whole bunch of view models, database, repository, all this sort of stuff, I only had to write once. I did not have to write for both platforms. So all of this logic that will maintain all the data connection, all of that, only had to write once using Firebase for the database, but I don't have to write it multiple times for multiple platforms. What we can notice in here is we might notice as I'm moving around the screens, you can see in the Android one, the screens are dissolving, which is what we're used to with an Android phone. But if I look at iOS, they're sliding. So there are still some interactions that are different between the platforms. And depending on how you write your UI, you might notice more of these. I'll show you another example in a moment. But we can see that we've got different behaviors, like the way we scroll. Actually, I don't need to scroll on this particular page. Let's grab another one I do. So we can see this one has no bounce, but it does have that sort of pull out down here. Whereas this one has a bit more of a bounce when you pull down. So you do see some sort of native creeping in, which is quite good because people who are used to the native apps will be used to navigation working differently and things like that. I'll go back into my presentation. So if we've got some stuff that we're sharing, what about the things we don't want to share? What if I do want different UI for both platforms? We can use expect and actual. So this is where we tell the system that we're expecting something and we want each of the platforms to give us the actual value. So it's sort of like promising something or perhaps an interface where you're expecting something and you have each platform implement that. So a really simple example is if we're just going to pass some text. So if I've got this platform object here, I can have an expect function. So whenever I call this get platform function, it's going to return a platform. That I put in common main. Then in the Android platform, I have the implementation of that platform class, and then my actual function will pass that implementation back. So I'm passing back the Android string in this case. For iOS, I have the iOS platform. I can then just pass that implementation back through. And I store these in different parts of the file structure, and that will help me know which one will get called. What about something a little bit more complicated? So if we want to have something that we need to do a little bit more for and use some of the native functionality, we can, again, use our expect function. And this time I'm going to use dependency injection to inject a whole class. So I've got a platform module, which is going to have a list of modules. So this is dependency injection in Coin. Then I have a share service. So I want to share my app on both platforms using the native share sheet so that I can share it, text it to a friend or share it on Facebook, that sort of thing. So I've got my share service. I know it's going to have a function called share app, and I know what the inputs for that are going to be. My actual function, I can implement even the dependency injection. So on Android here, we have the platform module, and then I've got my single there, and I've got my share service, and I'm injecting Android context into this because I know that on Android, I need the context to be able to do a share. Then my implementation, in my original expect, if we have a look, I didn't actually say that there was going to be any passed in context, but I can provide that implementation when we have injected that context in Android. So then in my share, I've got actual function for the share app. I would create my intent, start the activity, all the stuff you're used to if you're developing Android. It's all native Kotlin code. For iOS, again, I can inject using Coin the implementation of iOS share service. In this case, I don't need to have the context at all because iOS has no concept of context, so I don't need to pass it in. And I'm going to use the interop API in order to write Swift code within Kotlin. So I can use this API to write all this in Kotlin. If I wanted to, I could also provide this implementation in Swift if I so chose. But it was easier for me to write this in Kotlin, and also I made Gemini do it. So So we can do this as well, which is really cool. Not everything is enabled in the Interop API, but they're increasing it, and it is beta at the moment, so it is changing. So keep an eye on that. But we can see here, I've just got the native implementation of how to launch the share service. And then when I run this on both apps, we can see I've got the native share ability on both apps. So on the Android version, I've got some extra text in here because that's what we're used to with Android, whereas iOS just shares a link. So it's quite different how it behaves on each platform, but people who are using this app will get their native look and feel, which is a key thing for something where I want them to interact with. And so you can do this kind of thing for many different pieces of your app, depending on what you've got. You can implement a native camera, for example, so you can implement a Kotlin Multiplatform camera where you've already written the logic once, or you can hook into each platform's camera if you want to, for example. But there's different choices you can make depending on what native features you want and what look and feel you want. So that's one of the next lessons is the adoption can be on your terms. You can mix and match Compose Multiplatform and Kotlin Multiplatform as much as you want. You can have Compose in Swift UI or vice versa, so you can embed them in each other and then use what makes sense to you. And it's got full backwards compatibility, so you don't have to worry about the user having the latest device or latest operating system. You can choose which parts you want to migrate across from an existing app. So some of my recommendations, if you're going to take a look at Kotlin Multiplatform, is start really simple. Don't start with authentication. Just build something simple first and then gradually add some of those features once you get everything working. For an existing app, you can actually migrate module by module. And all you would do here is add that Kotlin Multiplatform plugin and change your dependencies. As long as you're using dependencies that would work. And you can migrate individual modules, which means they can exist in your current Android app, quite happily interoperative with Android. And then when you're ready, you can migrate the final amounts, the UI, for example. So you can gradually migrate these bits and pieces, make sure they're tested and your users are happy with them before you migrate the entire app. And you might think if you're an Android developer, focus on Android first, just test all of Android. That's lesson number 5. You do need to test on all platforms constantly. An example of this was I was testing, this is the Android version. I was testing my register screen with just a 1-character password. I got a nice message, given password is invalid, should be at least 6 characters. Yeah, that looks fine. When I tested the same thing on iOS, I got this lovely error message which does not make any sense to any end user. And what is happening here is I was using the default error message that came with my Firebase SDK. In this case, the GitLive SDK. And they were, I think, passing it directly through from the native SDK, so Firebase on Android and Firebase on iOS. What I didn't realize was that they have different implementations. So on Android, the error message was okay. On iOS, I just got this unholy hell message. To fix this, what I did was catch the correct exception and put my own message out that was nice and easy to read. But this is the key thing, is that even though you've got functionality on both platforms, the underlying code might be different. So you can't just rely on the fact that when one platform works, the other platform will work as well. So you need to not focus just on Android, test on all platforms constantly. Constantly check, make sure all your functionality is working. So even if you can save a lot of time in your development time, using Kotlin Multiplatform, you do find that you do need to test both equally. You won't really save a lot of testing time, especially for some of these edge cases, which you might not notice frequently. My advice as well is if you're thinking about making a new app, just build for KMP anyway, even if you're only going to work with it on Android. It gives you the option in the future of just launching an iOS version if it's successful. You might need to make a few tweaks or do that testing, but if you've already done the work to make sure you've got the right dependencies and the right structure, then you're okay just releasing it on one platform. And also find your iOS friends, because when you get some of these weird error messages, they may be able to help you. Luke's shaking his head over there. If you come regularly to GDG events, we have our coding night where we have our Coca Heads friends come along as well. I just came and monopolised their time. So it's a really good idea to come and make friends with people from other platforms, web platform if you're planning to launch this on web as well. So you can get help with some of the little intricacies that you might not be used to. And then you get to make new friends in the process. Another lesson, I used Gemini actually a lot for this, mostly because I was doing a lot of the development late at night and I couldn't be bothered thinking through logic. I also asked it a lot on explaining iOS things to me, like how to use Xcode, and I would then add it with, like, explain it to me like a 5-year-old, because I just had no patience for not knowing what I was doing. So that was definitely helpful, and it was surprising how much it knew about Kotlin Multiplatform and was able to direct me to the right places. Some interesting libraries to look at. I haven't looked at these ones personally myself or tried them out, but they're ones I'm going to look into in the future. So this one, Carve, this one is providing an adaptive look and feel. So it's providing native-like components in Compose that you can use in your app. So for example, the alert dialog. So making an Android version and also an iOS-looking version so that people using iOS might feel more familiar with the user interface. I think this is quite a good idea, and it will be using things like that expect and actual under the hood. But if somebody else can do it for you, then it saves you a lot of development time. There's also quite a few of these like all-in-one libraries which are providing a lot of functionality, like that share sheet example, where it's providing you native functionality in each platform in one library. What I would caution with some of these libraries is take a look at who is maintaining these libraries, because they might look all really good now, but if the maintenance runs out and they're left, they'll get left behind, you might be using something that's not getting the latest updates, that might not interact well with other libraries and dependencies, like what I was experiencing with GitLab and Firebase. So these libraries, while they look really cool and might save you a lot of time, take a look, what features do they support, what testing has happened with them, and who is maintaining them and how often. So we're ready to go for a coffee run, do a quick app with Android and iOS. My nephew definitely thinks so. He's a big fan of a baby Trino. Here's some useful links. Generally searching for Kotlin Multiplatform will send you to the JetBrains websites, which is pretty much one-stop shop for that. Also Android, at the Android documentation, there's a whole bunch of Kotlin Multiplatform resources and code labs and things, so definitely check that out as well. And any questions, if you want the slides, you can grab that off that QR link or on my website. Any questions, Michael?
Well, I've got a MacBook at work. My home computer runs Linux.
Tricky.
Do you think KMP will let us make iOS apps outside of running on a Mac?
I doubt it. I reckon they want to, but I reckon that somehow Apple has put something in there that will only allow simulators and apps to work only on Mac hardware. If you have a look here, I'll put Android Studio here. If I want to run my iOS app, I do need to have, I do have to have Xcode open. So I haven't done anything with Xcode, it's just sitting here in the background. But if I close that, then I will lose the iOS app here, and I won't be able to deploy to iOS.
Keep an eye on it though, because Apple has open sourced all of their build tools in the last 9 months.
Okay.
So it's quite possible that all of the build tools, you won't be able to run it in the simulator because it's tied to Apple Silicon. So you need unless you're running Linux on an Apple laptop, but even then I think you're going to struggle. But you might be at least able to build the binary out of the system. Like I said, it's been 9 months since they've released all of the build tools that are basically the guts of Xcode.
Okay.
Is now open source.
Well, that's cool. So there might be hope. We'll see. Any other questions? Yeah. I chose KMP because I am already an Android developer and I don't know any Dart, so I know Kotlin. I just wanted to also investigate it. And interesting thing to me as well was in the apps that I have that are pure Android apps, I wanted to see how I could replace individual modules, which, as I mentioned before, if you're building just Flutter, you have to only build in Flutter. You can't replace individual pieces. Whereas I could reuse a lot of the UI that I've used in another app in this app. So there's more reusability for me, given I already have a lot of Android apps. But if you're a Flutter developer, well, choose Flutter. But if you're an Android developer or a Swift developer, because you can include Swift code in here as well, that's probably more the choice. And we'll see. I don't know which one's going to win the cross-platform wars. We'll see. There does seem to be a lot of support behind Kotlin Multiplatform, but with like any technology choice, it completely depends on what you want to do.